Managing name resolution issues. Hot on the heels of our discussions of A, logon issues, and B, network access issues, we have this discussion, and that is dealing with host name and possibly NetBIOS name resolution failures in a Windows 7/Windows Server 2008 Active Directory environment. To that end, we're first going to look at the mechanics behind name resolution. Exactly what does it mean? What is the name resolution order that Windows 7 uses? And so on. We'll then look at some management strategies, some practical information in terms of managing the DNS resolver cache on the client computer. In this nugget, I'm going to sprinkle a lot of server-side config as well, even though that's typically a bit beyond the reach of many desktop support technicians. The reasons why I do that is A, to make sure we're fully covered for the 7685 exam, and B, to give you an understanding of how DNS works on the server side as well as on the client side. That can do nothing but improve your troubleshooting effectiveness. Third, we'll examine nslookup. This is a TCP/IP standards tool. We're going to look, of course, at the Windows implementation of nslookup. Very handy for us administrators to use to verify DNS records and troubleshoot problems. Let's get to work. Name resolution order. Before we get into this resolution order specifically, let's make sure that we both understand what is meant by name resolution. Now, we're assuming that our network is TCP/IP based, and as we've talked about in the previous couple nuggets, hosts on a TCP/IP network are identified by this logical address called the Internet Protocol address, or IP address. Now, what would you rather do and what would your users rather do? Communicate with network resources by having to remember discrete IP address numbers or by using friendly names? For instance, would you rather tell the user, well, open up a run prompt and do / 192.168. whatever, or would you rather have them go into the network utility and browse to find the server named SRV1? I think we know the answer to that. Of course, on a large scale, we know that the World Wide Web or the Internet is fully reliant upon DNS, so we can type www.cbtnuggets.com instead of having to know the IP address that's associated with that web server's interface. Alright, so I think I've made my case that name resolution is crucial for user-friendly computing and information technology. The question now is, what does your Windows 7 workstation, which in this context is called the DNS client, what is the order that that client computer is going to use in the attempt to map, say, SRV1 to that local file server or local web server's IP address? Here's the general flow. It's 3 parts. First, your DNS client is going to attempt host name resolution. Nowadays in 2010, I hope that we've moved away, or your shop has moved away from NetBIOS names, which we'll talk about in just a second. And instead, when we refer to a user-friendly computer name, Workstation 1, WKS1, Server 1, whatever it is, we're talking about a TCP/IP standards-compliant DNS host name. And in terms of host name resolution, there's 2 paths to go. I'll call these A and B. First, the DNS client will look at its hosts file. This was the original way in the early days of TCP/IP networking that TCP/IP hosts would resolve names to IP addresses. This is a static, individually maintained text file that contains nothing other than hand-coded mappings of host names to IP addresses. Now, as a troubleshooter, as an enterprise support technician, you should always suspect that maybe a rogue entry has gotten into a user's hosts file, and that's what's preventing the user from connecting to a network resource. I'll give you a real-world example. Maybe you've swapped, for whatever reason, the IP address out on a file server, and 1 or more users are having problems accessing that server. You think everything looks fine in DNS, but sure enough, if you browse into the hosts file directory on the computers that are affected, there's an old entry there that was hand-coded by, say, another administrator that points to the old IP address. The host's name is parsed before DNS queries are set up, so never overlook the hosts file in your troubleshooting name resolution. The second step is if there's an empty hosts file or if there's no mapping in the hosts file for the target host, to consult the primary DNS server that's associated with that client computer. DNS, as I'm sure you know, is a distributed database. The database of host name to IP address mappings is organized in what's called a zone. So if we are part of the nuggetlab.com Active Directory domain, you can rest assured that we have a zone file that's either a standalone plain text file that harkens back to the earliest days of TCP/IP, or more commonly in Active Directory networks, the DNS zone is integrated directly into the Active Directory database. There are many advantages to that approach. Regardless, as I said, the DNS zone file contains those mappings, and the client can request of the DNS server that IP address. If the DNS server is authoritative for that zone that contains the host and or has the mapping in its local cache, then the client computer receives a response and all is good. We're going to look at some DNS specific settings in just a moment. The second step in name resolution order, if host name resolution fails, is to invoke a fairly new protocol. This is a Microsoft proprietary networking protocol called Link Layer Multicast Name Resolution Protocol, or LLMNR. It's quite a mouthful. Try to say it 5 times quickly, for instance. All you need to know about LLMNR is that you're, in all likelihood, not going to be using this in an enterprise network. Remember in a previous nugget I mentioned a PIPA, automatic private IP addressing? This is that IPv4 strategy that was originally designed as a way for really small home networks or perhaps small home office networks to deploy IP without having to have a DHCP server and without having to know really anything about how IP functions. Well, LLMNR is the same idea. It works both with IPv4 and IPv6. What it does in a nutshell is it provides link local name resolution services in the absence of a DNS server. Normally, with host name resolution, if you don't have either a hosts file or a DNS server available, you're just not going to be able to resolve that host name to an IP address. LLMNR will step up to the plate and allow resolution to take place using, again, multicast, which is convenient, again, for a small office, home office, or a personal network. But nowadays in 2010, as I've mentioned in previous nuggets, you've got DHCP services available for $50 or less if you set up say a wired or wireless home router. Therefore, I would say that LLMNR has very limited utility in a business network, but nonetheless, you should definitely know what it is, at the very least, before you take your 7685 exam, which you now do. Third and finally, we have NetBIOS names. Now, a little tiny bit of history. NetBIOS is what's called an Application Programming Interface, or API. It's been around forever and a day, since the very earliest days of Windows, and even going back into MS-DOS, which immediately calls to mind legacy. Really, the only time your business should be supporting NetBIOS is if you have legacy applications that are bound to NetBIOS names. In other words, you cannot escape it. NetBIOS gets a bad rap because it's so clunky, so inefficient, so slow, so chatty, and in most cases limited, again, to link local or single subnet communications. Back in the early days of Windows, we had the NetBEUI protocol, and that provided name resolution for these NetBIOS names, but again, without something like WINS or the Windows Internet Name Service, you could not get those NetBIOS names through a router interface. You were limited to just a single net. WINS, believe it or not, is still available in Windows Server 2008, intended primarily for legacy operating system and legacy line of business application support. Similar motif between NetBIOS names and host names, in as much as for doing NetBIOS name resolution, the client will first consult a static text file located in the same directory as hosts called LM hosts or LAN manager hosts. Same exact idea, a mapping of this time NetBIOS names to IP addresses, and then the enterprise database version of NetBIOS management that's an analog to DNS. We have the Windows Internet Name Service, or WINS. NetBIOS names, you might recall, are limited to 15 characters. When you give your workstation a name in the system control panel, you're actually assigning both of these names simultaneously. Of course, the host name can go far more than 15 characters. You'll want to be careful if you are in an environment that has to support NetBIOS to make sure your host names are 15 characters or less. Otherwise, you're going to get truncation when you're doing NetBIOS communications, and that can do nothing but complicate things in terms of enterprise support troubleshooting. Windows 7 DNS configuration. Of course, we can do static DNS if we want to, but in practice, any enterprise network worth its salt is going to distribute DNS information via DHCP. Specifically, we have in Windows implementation of DHCP, option 6, where we can give one or more DNS server addresses to our clients on the scope, and option 15, that gives the DNS domain name suffix, for instance, nuggetlab.com. Now, speaking of the notion of the DNS server, I mentioned that you can have more than one of those addresses, and certainly that's a great idea. Why do you think it's a great idea to have more than one DNS server for your clients? You got it. If you answered redundancy, you were absolutely correct. If the primary DNS server is taken offline administratively, well, our client computers are going to be in a world of hurt as far as name resolution goes. Therefore, we want to make sure that we populate our users with the IP addresses of more than one DNS server. Of course, there's the idea that users wouldn't even be able to log on if DNS is unavailable, because remember, as I mentioned earlier when we talked about troubleshooting logon, it is those service locator or SRV DNS records that enable the client computer to find a domain controller to process that logon. Another really nifty advantage that we saw in Windows 2000 Server and still carries forward now to Windows Server 2008 is that of DHCP-based DNS dynamic update. Now, what's so awesome about this is that whereas DNS, when it was originally implemented, involved administrators having to manually add, edit, and remove those DNS name records, with DNS Dynamic Update, we have our DHCP authorized server in Active Directory registering and unregistering host and perhaps pointer inverse lookup records on behalf of clients in that domain. Isn't that great? Therefore, the net effect is that DNS becomes largely self-sustaining. As your client computers come online and offline and receive perhaps a new lease from DHCP, you as an administrator don't have to intervene. DHCP will take care of the DNS for you. Now that's something you need to specify in the DHCP console, and I will show you that for grins in the upcoming demo. Note also that this does require the client computer's participation, and I'll show you that in the demo as well. The good news is that by default, Windows 7 TCP/IP stack is set for dynamic update by default. Now, a little bit beyond our scope, but to give you this extra information, in an Active Directory environment, you can enable secure dynamic update. The idea here is you want to prevent rogue hosts from registering in your DNS database. You want to do what you can as an administrator, in this case an Active Directory domain administrator, to ensure that only domain member workstations and authorized other hosts, for instance switches, routers, wireless access points, network printers, etc., are allowed to register with your DNS zone. And to do secure dynamic update, you have to first of all make sure that your DNS zone is integrated in the Active Directory database. Once you've done that, you're able to create what are called access control lists, or ACLs, where you can specify which hosts are allowed to dynamically update, and anybody else, like if a contractor were to come in with his or her laptop and attempt to come online in your network and register with DNS, that attempt would be blocked. And of course, that has a nice security benefit, because then that user would be unable to resolve host names on your network. You might or might not know that fingerprinting, or as it's also called footprinting, is the first step that a malicious user, aka a hacker, is going to do to see what's what on your private network. What are some strategies for troubleshooting DNS problems? A little bit earlier in this series, I showed you some command line tools, some of which are tailored for DNS and name resolution troubleshooting. When a client computer hits up DNS for a resolution and the DNS server is authoritative for that record, let's say I want to look up srv1.nuggetlab.com, and we're configured to associate ourselves with NuggetLab, so we're within the same zone, as it were, that DNS server is going to give us the record that contains the host name and the IP address, but that record is also going to have what's called a time to live, or TTL, that is administrator configurable on the DNS server. TTL value determines how long that mapping can exist on the client computer in memory in what's called the DNS resolver cache. As I showed you a little bit earlier, and will repeat again in this demo, we can use ipconfig to display the DNS resolver cache on that machine, as well as flush it if we feel feel that one or more of the entries is no longer valid. Another sometimes overlooked thing for enterprise desktop support technicians to ensure is if a user is having a failure, a complete failure actually, in name resolution, open up the Service Control Manager on their machine and ensure that the DNS client service is running. If, moreover, the user shows up with all zeros for their IP address and just can't get on the network at all, make sure that the DHCP client is configured as well. Somewhat related, you'll notice I didn't create a bullet point for it. We have a command line tool called NBTstat, and NBT stands for NetBIOS over TCP/IP. If you are doing NetBIOS name resolution in your network for whatever reason, hopefully you're not using it just because nobody knows any better, you're using NetBIOS over TCP/IP. NBTstat is a command line tool that we can use to examine the NetBIOS name cache. I hope you see that there's really a direct analog relationship between host name resolution and DNS and IP config, and then NetBIOS name resolution with the NetBIOS name cache, NBTstat, and so on. By the way, I'm going to show you how to disable NetBIOS on the client if you feel that, look, we don't need NetBIOS, let's see if we can get away without it. To finish up this whiteboard, we have nslookup. NS stands for name server, and traditionally when we refer to name servers nowadays, we're referring to DNS. nslookup, as I mentioned earlier, is not just in Windows, it's in any operating system that supports TCP/IP, and it's going to give you read-only access to any DNS server that you point to. Now, if you're being careful with your security, you're going to want to be really careful as a DNS administrator on how you have that set up so that a malicious user or an inappropriate or unauthorized user is not going to see much of anything if they query your DNS database. To do a full listing, or ls if you're familiar with that command from Unix Linux, of a zone file is going to require that the DNS server allows zone transfers to occur. That's a huge security breach because, as I said, if a malicious user penetrates your campus, even to a light degree, they could do this from home potentially, and do an nslookup, focus on your DNS server, and attempt to dump your entire zone file, if you as a DNS administrator aren't restricting zone transfer, then you've given that malicious user a full map of all the host names and IP addresses on your network. That takes you past footprinting and into what's called service enumeration. For instance, they can find an MX record and say, oh, okay, mail1 is their mail server and it has this IP address. They can look at the SRV records to identify domain controllers. They can look at host names that might start with PRT and say, oh, those were network printers. Now, the good news is that Windows Server 2008 is set pretty well as far as zone transfer restrictions, and you can customize that. You would definitely, as a desktop support technician or enterprise administrator, want to configure DNS to allow zone transfer to you, but not as a general rule. In this demonstration, we're going to examine DNS client-side configuration in Windows 7, as well as DNS server configuration in Windows Server 2008. And then we'll complete the demo by examining some of those command line troubleshooting tools to counteract name resolution problems. We're going to begin this demo from WinNugget, our domain member workstation. Let's start by examining DNS configuration on this box. What I'll do is I'll open an elevated command prompt first to make sure that we don't run into any authentication issues. Then we'll run ipconfig/all to see what's going on with our network connection. What we should see right off the bat here is that we are in fact set up as a DHCP client. You'll see for DHCP server, we're connected to 10.0.0.1, and we'll also want to verify that we're pointed to the DNS server at that same IP address. Now, we talked about the issue, if you want to call it that, of NetBIOS and NetBIOS over TCP/IP. The bottom line being, if you don't need it on your network, I would suggest disabling it. You see that we're enabled by default here. Let's go into our search box, open up our Network and Sharing Center, come into our adapter settings. We'll right-click this guy, select Properties, and then dig into TCP/IP v4. Sure enough, this information on the General tab bears out what we learned in the run of ipconfig. Now, though, we'll click Advanced and go into the Advanced TCP/IP settings. Now, because we're DHCP enabled, you notice that these buttons are not available. If we were doing static IP addressing, you can actually associate more than one IP address with a single network interface. Next, we'll come over to DNS. You can add additional static DNS entries if you want to, besides what's given to us from the DHCP server. Remember I mentioned dynamic update earlier. That's this option down here that is enabled by default in Windows 7. Register this connection's addresses in DNS. Therefore, if for whatever reason you want to disable automatic DNS update on the client level, you would untick this box and click OK. By default, the computer is going to receive its suffix, its DNS suffix, from, in this case, DHCP, and I'll demonstrate that on the server side in just a minute. However, the middle part of this box allows you to add additional connection suffixes if you want to or need to. This can be useful if, for instance, your machine is trying to resolve an unqualified name. In other words, just the host name portion, and you want to speed up name resolution. Let's say we had nuggetlab.com and corp.nuggetlab.com. If we do a search for, say, SRV1, by default, the client is going to append the primary connection suffix, which in my case here is nuggetlab.com, to that host name. It's going to take longer to walk the DNS tree and eventually get down to corp.nuggetlab.com to find that host name. So the whole point here, and you can configure these alternate DNS suffixes in DHCP as well, is to pre-populate some of your other DNS domains to speed up name resolution. Simple as that. Now in the Wins tab, which you hopefully won't need, you can selectively disable parsing the LM hosts file if you're not going to use that. And also, the default setting is to use the NetBIOS setting from the DHCP server, but we can come here and explicitly disable NetBIOS over TCP/IP if we're sure we don't need it. There is a gotcha to that, though. Let me come back here. You want to be careful about just disabling NetBIOS on your network until you're absolutely sure that your line of business applications, and sometimes even Microsoft Enterprise applications, do not need NetBIOS. Okay, so definitely that's something that you'll want to test before you just go ahead and do. Now, because I have the RSAT tools on this workstation, I'm now going to open the DHCP console, make a connection to DC Nugget. That is our authorized DHCP server in this domain. I'll right-click the root node, select my authorized DHCP server, and away we go. We'll just focus on IPv4 here. You'll note that I have a scope for the 10.subnet. That's actually what's going on. If we look at the properties of that scope, I want you to see that on the DNS page, this is where you specify on the server side DHCP-based dynamic update. And this is just the out-of-box defaults for Windows Server 2008. Enable DNS dynamic update. Dynamically update both the forward lookup, or A record, as well as the inverse lookup, or PTR records, only if requested by the clients. And as I just showed you, the default client setting is to make that request. Alternatively, we can force DHCP to always dynamically update those records. A helpful option as well is to do the opposite, to unregister or discard those old records when a lease is deleted. And then finally, there's an option to enable dynamic update for clients that don't support dynamic update requests, like NT. That's for your serious down-level clients. I also want you to see my scope options here. I've plugged in option 3. That's for our router or default gateway address. 6 is our DNS servers, which actually it looks like this is set at the server level, not the scope level. I want you to see that specifying additional DNS servers here is just as easy as adding in a new address and clicking add. Note the up and down buttons. You'll want to make sure to order your DNS servers for your clients in descending order of reliable connectivity. In other words, if you have a DNS server on 3 of your 5 subnets, when you're handing out options to each subnet or each scope, I would do this as a scope option, not a server level option, and make sure that the DNS servers are listed in the order of the closest DNS server to that host group, if that makes sense. I'm probably over explaining this. You just want to make sure the servers are as easy to reach as possible. Just some common sense there. So much for the DHCP server. Let's again open Administrative Tools and now open the DNS server. I'm going to specify in RSAT that DNS server is running on DC Nugget and not the local host. We'll expand our forward lookup zone, and now we'll take a look at the properties of nuggetlab.com. Here, just to give you a general tour, on the General page, Dynamic Updates, this is where we can specify non-secure and secure, no dynamic updates, or secure only, which is the default I have. Start of Authority deals with things like that time to live value. You notice we have refresh interval, retry, expires, and then there's our time to live. Where we really want to go to, I'll just give passing reference to this. If you are using WINS for NetBIOS name resolution in your network, you can configure WINS to, as this says, to resolve names that are not found in the DNS namespace. I mentioned earlier that by default your NetBIOS names and your host names are the same thing. It's simply your computer name. For instance, if I right-click Computer and go to Properties, we can come down to where it says Computer Name, Domain, and Workgroup Settings. We have a computer name field, and then the full qualified, what's called the FQDN, the fully qualified domain name of this computer. And again, not to take us down a rabbit hole, but to bring us into the Change Settings area, we can click Change, and this is where we specify the computer name. If we click More, check this out. This is where we can manually pop in a DNS suffix, and you'll note here, this is a read-only field. It gives us the NetBIOS computer name. So I'm here to tell you that if we make that host name longer than 15 characters, like I've just duplicated WinNugget, the DNS name can accomplish that with no problem, but check this out. If we go to More, you'll note that NetBIOS has truncated that name and made it really non-intuitive, big time. That's one of the gotchas I told you about. Associated, you could have WINS take care of resolving names in the case of a truncation, for instance, where you're not going to have the same name stored in both WINS and DNS. Just something else to consider. Finally, on the Zone Transfers tab for the DNS zone, you notice that zone transfers are disabled by default. The chief reason why you'd use zone transfers in a traditional DNS environment is to provide backup and redundancy for your DNS zone. For instance, you might have a read-write primary zone DNS server that's periodically transferring its zone changes to one or more backup or secondary DNS servers. That kind of goes away if we're doing Active Directory integrated zones, because Active Directory replication takes care of zone updates. Alright, so if we want to allow zone transfers selectively, you can just do that to any server, which is obviously not secure, only to servers listed on the Name Servers tab, or only to the following servers. And then if we click Edit here, we can add an IP address or DNS name. So if I want to add in WinNugget, I'm able to do that. And you'll notice that both the IPv4 and the IPv6 link local address are now associated with the FQDN of WinNugget. So I can use nslookup now to its fullest capacity. Let's now head back into the command line environment and take a look at some of the aforementioned tools. We'll clear the screen, and just to make sure we've covered it a little bit, let's look at NBT Stat. As the online help tells us, this will display protocol statistics and current TCP/IP connections using NBT, or NetBIOS over TCP/IP. The most common flag is the cache flag, which is -C. I'm using strictly hostname resolution here, so there's nothing actually in my NetBIOS name cache. Another popular option is the -RR uppercase. This is a release and a refresh. You're going to use this pretty much only when you're in WINS. The NBT stat -RR is directly analogous to ipconfig register DNS, which is going to force a re-registration of this machine's host name and IP address with its authoritative or primary DNS server. In fact, let me just one more time do a help listing so we can take a look at those. Remember, we have ipconfig release and renew for both IPv4 and IPv6 addresses. We can display our DNS resolver cache. We can refresh not just our DNS registration, but register DNS also refreshes all DHCP leases as well. That's pretty cool. Good and good. Finally, let's take a look at nslookup. nslookup supports two modes of operation. The one that we're looking at is what's called interactive mode, where we type nslookup with no other parameters, and it takes us into a separate prompt. We're in an nslookup prompt now. The other way to go is to pass arguments to nslookup right on the initial command line where you're kind of getting in and getting out. In my experience, DNS troubleshooting is most effective when we're using it in interactive mode. So we typed nslookup, we saw DNS request timed out, default server unknown. So nslookup is doing a whole bunch of nothing right now. So what we want to do is point our nslookup specifically at a server. There we go. We can also try server with the DNS domain name, nuggetlab.com. Once you're in nslookup in interactive mode, couple different ways to go here. If you're looking for specific record types, what you can do is set that type by using the set type command and then retyping the name of the domain. So I typed set type equals srv, and then I typed nuggetlab.com. We could also try set type a, nuggetlab.com, and it'll give us A records this time, dealing with that specific domain. To look up specific hosts, we can just type that host name. In this case, winnugget.nuggetlab.com, and it tells us the record it has. Again, type A or host, IPv4 host. My address is 10.0.0.10. Practically speaking, friends, this is a good troubleshooting tool for you because you can verify very quickly what is being stored in the DNS server for a host or for a server, as the case may be. So DC Nugget might be another thing we could try to verify that our domain controller and our DNS server is listening at 10.0.0.1. If you do a set type all and type nuggetlab.com, this is giving us basically the start of authority or SOA information for that authoritative name server. It's giving you the contact information if you have a responsible email address, your refresh, your retry, your expire intervals, as well as the default TTL. To finish this demonstration off, let me show you how to perform a full zone transfer if you just want to see the entire contents of the zone file. What I've been showing you so far is using the set type equals to run specific filters. For instance, we could do set type equals MX to look at mail records, AAAA to look at IPv6 host records, SRV to look at Active Directory records, or we can do what we're going to try now is to set the type to everything and initiate a full zone transfer so we can see specifically what's in the zone. To do that, we'll run ls-d and then the name of the zone. And you can pipe that if you want to a text file. If you pipe to a text file, you can capture the information very conveniently. Otherwise, if you just run ls-d with no other arguments, you get a nice run of every record in that DNS zone file, which very clearly demonstrates a security risk, doesn't it? We can type exit to leave, and now I'll run a directory listing. There's nuggetlab.txt. Let's type out the contents of that, and there we go. We have the entire zone. Very helpful for an Active Directory administrator to be able to do this, but certainly not something you want other people, non-administrators, to be able to do, much less folks outside of your organization. Managing name resolution issues review. In this nugget, we approached name resolution from several different angles. First, by defining the name resolution process in Windows 7, and then examining the name resolution configuration steps, both on the client side as well as the server side. Therefore, you should have a pretty well-rounded view of how name resolution works, as well as some of the gotchas in troubleshooting this. Specifically, on the client side, we looked at how to manage the DNS cache, and on the server side, we used the command line tool nslookup to examine a real-live DNS zone file. I hope that this has been informative for you, and I'd like to thank you for